Okay, thank you, Emily. This is a physics lesson. It's on magnetism, IGCSE physics, possibly for grade 10 or grade 12. So in this lesson, we want to study about magnetism and mainly to draw magnetic field. And from our IGCSE syllabus, these are the objectives that we need to. I want to take a minute and read the lesson objectives. Yeah.
Draw the pattern of magnetic field lines around a bar magnet.
Around a bar magnet, that's very good. And this is a bar magnet. Just a rectangular shaped magnet. That's what we refer by a bar magnet. Thank you. The next objective.
Describe the experiment to identify the pattern of magnetic field lines, including the direction.
Yes. So, that's the second. We want to be able to describe the pattern of magnetic field around a bar magnet. Now, you must have learned about magnets before.
Yes.
What do you understand by magnetic field pattern?
Magnetic field pattern is, it shows, can I say something very simple?
Yes.
It shows where the direction in which it attracts and repels from the North Pole to South Pole.
That's a very good try. A pattern, if I add something on it, a pattern is how the field lines run around the magnet. So our aim is to find out how the field lines run around the magnet. Now, there are some key vocabulary that we need to use all the time when you're dealing with magnets. So when you're dealing with magnets, there are key vocabulary, and you want this to come out in your statements when you're describing magnets. Some of the key terms are these. The first one is magnetic pole. Tell me what you know about that.
Magnetic pole is it shows the direction. It's like the North Pole. Is it something like North Pole of a magnet? The magnet shows the North Pole of the magnet if it's on the north side of the magnet or the south side.
Excellent.
It does shows the poles.
North.
Either on the north or on the south.
On the south.
Yes.
I just want to add something to that. So what we refer to as poles are the ends of the magnet. So this end is a pole and that end is a pole. And you can see they are written South Pole and North Pole. Let's look at something interesting about a magnet. If you put a magnet around, if you put iron filings around a magnet and you try to shake them, where do you find more magnetic fields? Where do you see the iron filings settled?
On this side, though I don't know which pole it is.
Yes.
I can't remember the pole. But they are all on this side. Most of them are on this side. This one has fewer.
Yes. But if you look at it, there are more at the ends. So magnetic poles are the ends of the magnet where its field is strongest.
So it can be on the north and on the south, but both of them are strong.
Yes, both of them are. So poles are ends of the magnet where the magnetic field is strongest. A plotting compass, I know this you've come across a number of times. Plotting compass, what is it?
This one?
Yeah.
It's a compass that shows direction, especially when you're going for camping or
exactly,
expedition.
Application in camping, yes.
Yeah, you use this magnet to show you which side is on the north and which side is on the south. According to the map that you're given, you know which direction you're heading to, so that you don't get lost.
Very good. So what do you think it's made of?
It's made of a magnet.
Yes, a plotting compass is a small magnet with one end, the North Pole, and we always use the North Pole to get our direction. That's very excellent. The next one, read the next terminology we want to know.
Magnetic field lines.
What do you know about that?
I think they are the lines that are formed at the end of the North Pole, that they make the North Pole and the South Pole meet.
Yes, and that's what we want to get. We want to get magnetic field lines. Yes, these are lines of forces around a magnet. That's our aim to get. The magnetic field?
Magnetic field. It's formed with the lines.
It's formed with lines. But what do we say? We have magnetic field, we have electrostatic field, we have gravitational field. So what do you think magnetic field is?
Sir, I think that one I don't know, but I think you have the best.
No problem, that's what you want to know. When you talk about magnetic field, is the area around a magnet where its force can be detected.
Okay.
Let's say we have this magnet. Please help me to remove it so that we don't spread it out. Thank you. If we have this magnet, it could be a very strong magnet. Do you think it will affect this compass if the compass is placed this far? Do you think this magnet will affect that compass?
Yes.
Maybe.
A little bit.
What about if it's placed very, very far, which we refer to as infinity?
I doubt.
You doubt.
Yes.
So the field around a magnet is the area around the magnet where its magnetic effect can be felt.
Okay. It's only where it is effective.
Yes, where it's effective. It's a strong magnet, the field will be bigger. If it's a weak magnet, the field will be smaller. That's okay. Now at grade 8, we study magnetic field patterns. Did you do this before?
Yes, we did.
What did you use?
We use magnets, different type of magnets. We try to place them together. We also use the iron fillings, and we placed them on on the magnet, and we could see the lines showing around.
Let's do that quite quickly. That's quite interesting. Let's see what you did.
Like this. Can I come on that side?
Oh yeah, good. Okay.
These are the magnetic fields.
I can give a suggestion. Why don't you put one, not so many.
Not so many.
Little.
Sprinkle like that.
Yes.
And then there's...
And even further away.
And even further away.
Even further away, a little further away, a little further away.
And a little further away.
Wow.
I think I'm drawing something. This is the magnetic field.
Okay.
Now you've said if the magnet field, the magnet itself is strong.
We can make it better if we tap a little. Wow, that is great. You have come up with a great magnetic field pattern. That is a magnetic field pattern using iron filings. Yeah, you did this in grade 8. I'm happy that you can remember that.
Yes.
The pattern we have made has a small weakness. What do you think is the weakness of this pattern?
Has a small weakness. I think the magnet itself is weak, and it's because I can't see the pattern the magnetic field lines being drawn from further, and then I can't tell the North Pole and the South Pole.
There you are. And that is the reason why we want to go further and use a different method of getting magnetic field pattern using a plotting compass. We can use iron filings. It gives us a perfect field, but it does not tell us about the direction.
Yeah.
So, have a seat.
Thank you, sir.
Let's look at how to determine the direction of magnetic field pattern using a plotting compass. We should always be very, very careful, because when the filings get into contact with the magnet, it's a big problem to get them out.
So they don't have to get contact.
We don't want them to get into contact directly with the magnet, okay?
Yeah.
So, in getting magnetic field pattern using a plotting compass, I hope that is visible. We will place a bar magnet. Assume we don't know where the pole, the north and the south pole is.
Yes.
Then we place a plotting compass next to the side of the bar magnet, and then show the direction of the north pole. Let's say if I put it here, the direction of the north pole could be here. Yes?
Yes.
And then we extend it just above that and get the new direction of the north pole. Okay?
Yes.
Then put it just above that and get a new direction of the north pole. And then when we join those lines, we will get the magnetic field pattern, and this time with the correct direction.
Okay.
You want to ask some question on that? Because I would want you to do this.
No, not for now.
You think you can give it a try?
Yes, I
Good.
think
There
I'll
we are.
try.
Let's get moving.
So this is the magnet.
Okay.
Mm-hmm.
Go ahead.
I go ahead.
Yes.
Okay.
So here we are.
This is the magnetic bar.
Mm-hmm.
I want to find the direction. So the North Pole from here, it shows here. You've said where
Do you want to start from this side? Then you can go around here. Mm-hmm.
I can start from this side and draw like this, the direction,
Great.
and then I skip the arrow and come here, and I will draw it like this.
Yes. Somewhere else.
The compass, I try it here.
Yes. Just at the end. Just at the end.
At
Don't
the
fear.
end, I draw the arrow. like
Good.
that.
Start another line. Start another line from the same magnet from some different point.
Okay. From some different point. Why don't I start from this direction? It goes like that. I move there. It goes like that. And I move here. It goes like this. I move here. It goes like that.
Excellent.
I
This
move
is standing
here,
out
it goes
perfectly.
like that. I move here. It comes back to the magnet.
Mm-hmm.
Now from this pole to this pole.
Join them.
Now,
Why?
let
Join
me
them.
join them. And that is how we find the
Excellent.
magnetic
Would you want to join this also?
This one, I think it went further.
It's
It
okay.
wanted to go further.
Just do it as it is.
So
As it
let
is.
me
Don't force it.
assume. Let me assume from here.
Don't force it. Just join the three that you
I
have.
just join like that.
Mm-hmm. Do you want a third one? Maybe somewhere in between?
Yes. So here, from here, I can draw. Let me put it straight. I can draw from here, like that, and from this point, like that. I can
Okay.
draw it like that on this other end.
Mm-hmm.
Oh, it's
Maybe you can
pointing
start
back.
from here. You can
Or
start
I
from
can
here.
start from here.
Yeah, no problem.
I can start from here, like that, and like that, and like that. So that's another one. I can do it on this other end. From here, it ends there. From here. That from here, that from here, like that. Do you know something interesting?
Yes.
From here, the force is going out,
Mhm.
and from this other end, it's coming back.
Very good. And that is my question.
Mm-hmm.
Let's look at the poles. Just turn the magnet so that we can see the poles. Yes. So, tell me something. The same statement you're asking using the poles.
Now,
The field lines are.
the field lines, they are pulling out. It's like they're coming out from the North Pole and coming in the South Pole. The
Emily,
force.
that's a very good discovery.
Mm-hmm.
That magnetic field lines are always out of the north
Mm-hmm.
and in to the south. That is a way you can assess yourself if you've drawn the magnetic field correctly.
Can I say something else?
Yes.
Now, since this also has a magnet, the direction of north from the compass and North Pole do not face each other. It faces the opposite direction.
And that gives us the laws of magnetism. What's the law?
The law of magnetism, unlike poles attract and like poles repel.
You're a wonderful student. And like poles attract,
And
like poles repel, and like poles attract.
yes.
Good. So we've come up with a very good magnetic field patterns.
Mm-hmm.
Please draw the shape of the magnet round. Good. Label the north and the south. Excellent, excellent. Thank you for coming up with a good magnetic field pattern out of the north and into the south. Now I have a question just to assess what we've done. Look at the lines. How close are they as they go? What happens to the distance between the lines as you go away from the magnet?
Like on this other end from this side, they move further from this direction down here. They have moved further. And like this upper part, it's close.
It's closed.
Yes. So this part, they are moving further. Meaning you've talked about the strength of the magnet.
I can rephrase the question.
Okay.
Look at the lines here. How close they are and how close they are. What happens to the spacing between the lines?
As they move out, there's a gap, there's a space. There's a gap, big gap in between. As they come closer, it's like they are moving closer. The lines are coming closer.
Excellent. And that, when you look at a magnetic field pattern, you can tell how strong the magnetic field is. The closer the lines, the stronger the magnetic field. The more spread out the lines, the weaker the magnetic force. So we have a very strong force nearer the magnet, and the force gets weaker as you go away from the magnet. And the farther you go, the weaker the magnetic field.
Meaning, when I go further from this, so I'll not be able to detect north and south from the pole, from the magnetic bar.
There you are. And if you go so far, where we say infinite distance, you won't detect the force at all.
Yes.
Now let's look at these three questions. I want you to go and write an X on 2 points with a very strong magnetic field.
With very strong magnetic field.
Yes.
2X.
2 points which have strong magnetic field based on the spacing between the lines. Give it a try.
2 strong magnetic field.
2 points with very strong magnetic field.
The places where we have arrows.
Yes, we are based on the lines, based on magnetic lines.
Based on these magnetic lines.
Yes.
Like this point here, it is the magnetic field. It's very strong. This point too, it's very strong. And this one also, as the magnetic lines are coming in, this point is very strong and this point is very strong.
Very good. Why did you say that those regions have strong magnetic field?
Because they are nearer to the poles.
Nearer to the poles?
Yes.
Use the word of the lines. What about the lines? How do the lines help you to know?
They are closer to each other.
Excellent.
They are close to each other. They are not spaced out and they are not further from each other.
Excellent.
Yes.
The closer the line, the stronger the magnetic field. So
Yes.
here, a very strong magnetic field and a very strong magnetic field.
Yes.
Thank you. Now, I have another question, just to assess ourselves. I want you to predict what would be the magnetic field pattern in that arrangement.
Magnetic field pattern in this arrangement.
Please. Out of the, into the, if you can remember, can you?
Yes.
Yes.
So, from one computer
To another.
to another. I know this one goes like this. It will go further like that. And this one also will go further.
And the north, the south?
And the south will come in. So they will meet somewhere in between.
They will join actually.
They will join actually. So if they are like that, if they join, so this one moves straight here. So they will come from north. Normally they move from North Pole into South Pole.
Good, that is excellent. I want you to try. How will this go and how will this go?
How will they?
Marvelous, you are.
Like that. Those are the directions, and the same goes to this side. Like that. The arrows point in South Pole.
Thank you
It's
very
like
much. That's an extension question, and I'm happy that you've given it your best try. So we can be given different arrangements, and we can be able to predict magnetic field patterns. Thank you.
Like that.
Yes.
Done.
Okay, have a seat.
Thank you.
So Emily, tell me 2 things that you've learned in this lesson.
I've learned about magnetic field, also the strength of magnet, and I've learned that you can always get the magnetic field, the actual magnetic field, using a compass.
Magnetic compass. Okay, that's beautiful.
Magnetic compass. And also, I've learned about the strength of the magnet. The farther it is, the farther the magnetic fields are. They are not very strong, but the nearer they are, that's why they're compacted. Is it compacted?
The closer the magnetic field lines, the stronger the field pattern.
They are.
The more spread the magnetic field lines, the weaker the magnetic force.
So if I move further with this compass, very further, I won't be able to predict the magnetic field of this magnet bar.
Okay, good. What is the advantage of using the plotting compass over using the iron filings?
I will know the direction.
Excellent. The plotting compass gives you the direction. The iron filings just gives you the pattern, but they don't the direction.
Yes.
Thank you very much for this lesson. I hope it was very useful to you.
It was.
Thank you.